presentation. And it's about a project called the Droid Badge Project. It's kind of a test for something we want to do for a celebration.
How many LEDs are on it?
I'm sorry?
This version.
It's
not the Phasma version
So
yet.
the idea was we wanted to do a project where people could learn a skill and have something cool to take away.
I'm out.
And the other part is we didn't want it to be any cost to you guys. It's just something fun and something you can put on your badge, your little stuff here, and take it with you. And this is basically what we're going to be building. That's what we've been doing, and what you guys and girls can take home. So, to get started, I'll give you a little overview. I'm going to talk a little bit about the electronics and the pieces on here and how you assemble the thing. The software that runs on there, because there's actually a processor on here. And then if there's any questions, I'll be happy to answer them. So, overview, what is this and why are we doing it? So, this guy came to me, I guess, it was, I forget what it was, but he asked me, hey, I got this cool idea of something that we can do, can you help me out? And so we brainstormed a bit, we were on Skype, and came up with a plan, and basically just pushed through it at the very last minute. So that's my fault, sorry. So he came up with the idea, and then this is the culmination of the thing. So what is it? It's this electronics board that, of course, you know me, has a RGB LED on here, has a little processor, and then has another LED where the hull projector is. So I kind of whipped up this design of, let's put an R2 dome on here, and let's put these pieces kind of where they would be cool on R2, and of course I heard where the PSI would be. And there's this marking for DroidCON. The idea would be for different conferences we can change that out and expand upon this idea. The other thing was wanting to be self-contained, so it could be run by batteries. So it takes these two cells, you plop it into this thing, and what it does, and all it does, is blink red and blue light, and then cycle through all the different color hues because it's an RGB. That's all it does. But the cool thing about this is there's a processor on here, and you guys can program it to do whatever you want to do. So I wanted to make it very few components so that it's really easy to make. I wanted them all be SMD because I just gave you a whole presentation before that you should be doing SMD stuff, so that this is an excuse to give you time to try it out. Now, because of logistics and I didn't anticipate what it would take for everyone to do hands-on, we made a whole bunch, and by we I mean Steel.
Not just me.
And so 3/4 of them are already made. Well, we try to make 3/4 of them. We have some duds, but there's still about 25 that people can make. We wanted to hold those back, so at least I gave this presentation. If you want to do it, you have the opportunity in the next day and a half. And so very few components, all surface mounted, except for the battery holder, which goes on the back, and this header, which is not needed for the operation. We use it as for programming. But you could run, if you wanted to have an extended battery, you could run it off of this thing. And that's pretty much it. Oh, the other thing is, a lot of people, when we were doing, I kind of soft launched it here and had people make them. One thing people forgot to do is on this negative terminal is actually put a drop of solder, so that helps make contact with the battery. But everything else is surface mounted. So, okay, you build this thing up, and you said it can be programmed, so, and there is a program on here, so what is the program? I wanted to make this as simple as possible. So I make use of a common library for driving RGB LEDs. It's this thing called, it doesn't show up well on the screen. It's called Fast LED. And I just want to show you how simple it is to use this thing. The first thing, this thing is important right here because there's one LED on the thing. This program could drive tons of LEDs if it wanted to, but we only have one. And there's a storage for that one LED. This is what the setup is for this program. It just basically uses that fast LED library I was telling you about. It initializes it. By the way, this code is going to be up online. So once you get your little board, and you can go home and use my project and change it to blink at different rates or do different stuff. But it's very simple. You initialize the thing. I said that there was a RGB LED and then there's another LED on there. That other LED is controlled by, it's called the SCK pin, it's the clock pin. It's controlled by that output equate, which is, I think, pin 1 or something. And I basically just turn the thing off. So in the program, very simple. I do some stuff for timing so we can get a nice synchronization. But it's very simple. These two lines turns that blue LED on and off. This next line here, again, it's not showing up. This sets a U for cycling through all the different colors of the spectrum and sets it for that LED some of the time. The other times it flips between red and blue. And basically that's the logic here. Hey, are we going through all the U's? No. Are we switching between red and blue? And then sets that color, runs through this loop. In fact, very, very simple. So what could you do with this? Well, you can just change this logic here. If you wanted to show different colors or you wanted to have a different rate or whatever, this is the whole thing. And you do need a programmer. On this board, you'll see these 2x3 header. You basically put a programmer, I use something called pogo pins, which means I can just push the thing on there, to reprogram it. All this stuff, I'm going to have a tutorial online to show you how to program it and the settings that you would use. But again, really, really simple. And that's pretty much the presentation of what it is. To make one, like I said, there's just a couple of parts. Steele or I can walk you through actually doing the assembly. The way we do the assembly here is a little different than the way I do assembly at home. Normally I just do this stuff with a soldering iron. We were doing mass numbers of them, so we're using a toaster oven and solder paste, and that's the technique we'll be using here. So what you will be doing is we'll give you a board with solder paste already on there. You'll be placing the components on the board, and we'll pop it into the toaster oven, cook it, take it out, put on the final pieces, which I talked about. That battery holder and that header. And there's something which is not on here, which is an extra wire, and that's because I made a boo-boo. And that extra wire.
Feature.
Air wire.
Yes.
You should teach people how to solder a very small wire.
Actually, that's right. I was trying to teach you how to solder an extra small wire.
It's agreeably.
And so I left that trace off there to give you practice.
It's a good learning opportunity.
And so there's another wire we put on here. But that's it. And when you finish, you take it home. You built it for the people who built it. And you attach them to your badge, put 2 batteries in there, and it'll blink until those batteries go dead. That's it.
Sweet.
And I'm wearing this hat because my daughter said I needed to wear it because Ben bought me this hat in front of my daughter. And,
I thought you left the bet.
and she said that I had to wear this at this conference. So.
So I actually have a technical question.
Yes.
Is this a project with the least amount of LEDs you've ever done?
I have done a project with 0 LEDs.
Whoa.
So,
Well,
And he's been, cringing from that.
technically no, because the Lifeform scanner only had 2 LEDs. These have, I mean, it's
Has
got
2.
the RGB
These
and
have 1.5.
yeah.
But one of the things I said is this was a trial run for something we want to do at Celebration. We don't know exactly what that is yet, but it's, think of this and then, okay, how can we make this useful? How can we make this cooler? And how can we deliver it to everyone going to Celebration in time for Celebration? We're not going to ask you guys to build them, but you'll get one. And so that's
If yours doesn't work, you don't get in.
Beacons.
one of the things we have a few ideas. We wanted to do this and then iterate. You know me, iteration. Any other questions?
Is this for the, at Celebration, is it going to be for the builders or for the general public?
For the builders. Only for the builders.
Yeah.
This is unique to us.
But Brett, 60,000 LEDs.
Okay. I've learned that anytime Mike says something to me, my answer is always, okay.
Is that how you wore the Goopy hat?
I'm sorry?
Is that how you got to wear the Goopy hat by saying okay?
Yeah, pretty much. Or I do. Okay, thank you.
All right.
So if anyone wants to build any, we're finishing up the first batch of ones, pre-built ones, so we can clear off the table and then have at most 25 people build their own boards. And for the other people, and I'm really sorry about this, I planned for 100 boards because we were supposed to have less than 100 people here, and so I was going to have extras, and that was not the case. We have more than 100 people here, 120 or something.
127, I think.
127.
Oh, 132.
132.
And we've had some duds on the boards. Some things got cooked too much or whatever.
Chris isn't that bad.
Hopefully every builder can get one, but maybe not every family member for every builder.
Right.
So I mean, I'm going to have a box of them, and you can come and I'll give you one. I'm not keeping track of who's getting what, so let's just be on the honor system.
I better get mine.
You will.
And we're doing our best, but I do want to have the opportunity for people who want to make them to be able to make them, because that was the other part of this is giving you experience making something and not just getting something. Okay.